Hey, Guillermo here. In today's video, we are going to discuss how we can approach a difficult question that say you are given in a job interview for a quantum research position in the quantum computing industry. Generally speaking, if you are applying to a research position, it's really important to have a strong background in quantum and of course in programming. But not only that, actually something that we are looking for is for profiles that combine both skills. So the best way to check that actually is ask for theoretical results via code. So the purpose of this video is going to see one of these technical questions and check how can we approach the solution. Actually, the question we are going to look at today was given in the 2022 PennyLane Code Camp. It was one of the more difficult challenges, but at the end of the video you are going to see that it's something that you can solve. Probably you already know what is the swap gate. It's an operator that acts in 2 qubits and basically flip the value between them. For example, if the input is 0, 1, the output is going to be 1, 0. The statement of the problem gives us a specific template that we can see here with some C0 gates, some Hadamard, and one unknown operator U. We are asked to define this U operator in such a way that this template is completely equivalent to the swap gate. When we ask this question to our candidates, we used to have two very different solutions. And it's something useful to check what is the background of that person. We can get like a machine learning style solution and a compilation style. The machine learning one is probably the most common to find and used to be to give an initial guess of how is going to be this U gate. So for example, we create an initial U variational circuit that depends on some parameters that we are going to introduce in the template. So after that, we have to create a loss function that checks how close is now all this template to the swap gate. So if we update these parameters regarding to that loss function, well, we are going to find an approximation to the U that we were looking for. However, in the other hand, this compilation style, what it's going to do is play with these properties that we have equivalence within one gate and another in order to find an exact solution. And that's the one that we are going to see today that actually is not so difficult. The first property that we have to know, and probably one of the most important, is that the swap gate has a specific decomposition. We can change the swap gate for these 3 C nodes. In case you don't know the decomposition, well, in PennyLane you can always ask for the decomposition of a particular gate. For example, if we run here this code, we are going to get this output here. It means that with these 3 C nodes we can build our operator. So with all of this in mind, let's take pen and paper and solve the challenge. So we want to find a U operator such as this expression is equal to this decomposition. If we check the left side of the equalities, well, seems like we are not bad. We have a C node here and we have this C node here. So let's not worry about that right now. However, if we check the right part of the expression, we have at the end a couple of Hadamards that, well, it's convenient if we remove them in some way. So how we can remove this Hadamard? Well, the trick here is use a change of variable. So we can say, okay, let's guess that U, this operator that we are looking for, is something like operator A, and then apply 2 Hadamards. So now we have a new variable that is this operator A. So what happens if now we put this definition in the initial template? Well, what we are going to have is the initial C node, then the 2 Hadamards. Now we apply U that we say that is A Hadamard, Hadamard, the C node, then again U, Hadamard, Hadamard, and finally the two Hadamars. So actually, the Hadamar gate is a special gate that 2 times the Hadamar is equal to the identity. So they are going to cancel. And we just remove, thanks to that, the 2 final Hadamars of our template. So now we can forget about our first statement. Now what we have to do is find an A operator such as this template that we can see here is equal to the expression that we were looking. So another thing that we can start to think is, okay, maybe we have here some Hadamars that it will be better if they are not there. Because here, in the composition that we are looking for, these Hadamars does not appear. So we can do the same idea that we just apply with a new operator. So let's say that A, our operator A, is something like Hadamar, and then a operator B. If we do that and we introduce this new operator in our previous template, we are going to get that now we have something like control not, Hadamar, we are here. Then we apply A, it means Hadamar, B. Then we apply these Hadamars. After that, the C node, and then we apply B, that again is Hadamar, and the gate B. So we have this expression that you can see here, that actually, with the same idea, we can remove here the Hadamars, they are going to cancel. So we have something closer and closer to our final solution. Great, so a quick summary of what we have until now. We give a new definition for our U operator. This is a operator that we don't know, A, and 2 Hadamars. After that, this A operator has been defined like 2 Hadamars and then a operator B. And now we want to find this operator B in such a way that this template is equal to the swap gate. So now we can see that, well, there are still here some Hadamars that we are not interested in, because we saw that in our expression, in this equivalence to the swap gate, there was not Hadamar. And actually, we can remove these 4 Hadamars using a little trick. And that's the second big property that we should know. And that's it, that apply Hadamars at the beginning and at the end of a control not operator is equal to just swap the control not. So if we apply that in our template, we are going to get that this expression is just the same, like apply the C not, then the operator B. Now flip the C not, so we get something like this, and finally apply the B again. So if we pay attention to this expression, we can check that we have 2 times the same operator. So let's call, for example, C equal to control not B. It means that actually C squared is equal to the swap gate. So the operator C is going to be squared of the swap gate. That this is something that we can look for it in the documentation, or actually it's not very difficult to deduce, but the square of the swap gate is equal to this expression that we are going to write here. Apply control not, then a control squared of x and a control not. So now if we have the value of C, we are going to have the value of B, then the value of A, and finally the value of U. But we can write it. in particular, we know this is the value of C that has this shape that we can see here. So it means that actually this expression here is the value of B, because we remove this first C naught of the expression. So we know that B is equal to this control squared of X control naught. So then, if we have B, we can get A, that is Hadamard control squared of X control naught. And if we have A, we can get U, so U is equal to Hadamard control squared of X control X Hadamard. This is our final expression of U. One time that we already have the value of U, it's very easy to check with PennyLane that actually this is a correct solution. We just have to run this script that we can see here, where first of all we are going to define the different gates of U, and then we are going to use this U definition in the structure of the template in the way that is defined in the statement. So one time is defined the template, we just have to ask what is the matrix of this function. So if we apply this final line when we ask for the matrix, we are going to see that the output is actually the same matrix that the swap operator. I know it could seem like a hard problem with a lot of properties that we have to know, but at the end are going to be always the same properties. We have to know similar tricks, and for this reason I encourage people to participate in this kind of coding challenge, because it's the perfect way to learn all of them. So I hope you enjoyed the video. Don't forget to subscribe to the channel if you want more content like this, and see you in the next one.